Let's talk about serial dilutions. The first thing is why. Why do we care? Well, it's relevant to us because our chemicals are stored in very high concentrations to save space. So that means that every time we go to do an experiment, we have to dilute it down to usable levels. And serial dilutions are a way that we can accurately create highly diluted solutions. So anytime we're doing our experiments, we're going to have to do serial dilutions. And it doesn't just have to be chemicals. We have to do it sometimes with cells and different cultures and whatever. So next thing would be what? What is a serial dilution? Well, as the name implies, it's a series of dilutions. It's when you're doing serial dilutions, you go one after another, after another, after another, until you get down to your usable dilution that you were looking for. The classic example of this is using dye, because it's very easy to see the changes in the concentration. So here we have a high concentration of dye, but as we continually dilute it, it gets lighter and lighter and lighter every time. So now let's talk about how. So these are the steps to how you would go about doing a serial dilution. The first step is usually looking at what the original concentration is, but sometimes that doesn't apply because you may have a pure solution, or you may just not need that for the question. It may just be asking you about final dilutions, etc. So the important part here is talking about dilution factors. You got to find out what is the dilution factor, and a dilution factor is just it's easy to think about it in terms of a part over a whole, or the amount of solution that you added from one tube to the next over the total volume of that new test tube. So in other words, your total is going to be what you added. This here again, it's going to be your solution plus whatever buffer or water you added to it. So if we have a serial dilution here, these are just roughly drawn beakers or test tubes or whatever. So let's say that this one is pure. And we're just going to take pure dye and add it to here. And we want this dilution factor, let's just say we take 1 milliliter. So we take 1 ml of pure dye, that's what's here, and we add it to this test tube. So this test tube's empty right now, so we're just going to put our 1 ml. So it's just sitting on the bottom there. Then we're going to add 9 mLs of water. Let's change color for the water. It makes the most sense for it to be, we'll use green water. Okay. So now we just added 9 mLs of water. So now our dilution factor here is going to be what we added. We added 1 milliliter of our solution over the total, which is going to be our 1 milliliter plus the 9 milliliters of water that we added over 10. So our dilution factor is 1/10. This here is 1/10 as strong as this. So the idea of a serial dilution is that now we take this dilution here that we just made and we dilute it again. So now let's take 1 ml of this. Let's go back and use our solution color. So now we're going to take 1 ml of this new solution and add it to the bottom of this jar. It's sitting on the bottom there, and then we're just going to add another 9 mLs of water. So again, we have what we added, which is 1 milliliter of the previous solution, and our total, which is just 1 plus 9, again, which is 10. So the dilution factor again here, in between these two, is 1/10. So in between both of these is 1/10. So that means that, let's do colors again. This is starting to get a little complicated, but hopefully you can keep it straight. So here, this solution that we first made is 1/10 as strong as this dilution, as this pure solution here. And this dilution that we made third is 1/10 as strong as the second one. But what's important to realize is that this is 1/100th of our original. And we get that by multiplying these two right here. So we multiply these, and this ending solution is now 1/100th, or an 100-fold dilution of our original. We're going to reiterate that, go over it one more time just to make sure that you understand, because it's pretty central to serial dilutions. So this is pretty much the same thing that we just looked at, except it has a nice pretty picture. So the difference here is that the sample starts as a 1 in 10 dilution. So this initial concentration is 0.1, and it shows that here. So then they take 1 ml, just like we did before, and they add it to 9 mLs of water. 1 is what they added, 10 is their total. So this is the dilution factor in between here. And as you can see, it's the same for the other two as well. So then for our total, and we can't forget that we have to multiply it by our original concentration. Last time we ignored it because our initial concentration was just 1, it was pure. But so this is going to end as a 1, and we got 1, 2, 3, 4 zeros. Oh, we forgot one. Here as well. We end with 5 zeros. 1 in 100,000, and that's reflected here. 10 to the negative 5. Okay. Alright, now let's practice some dilution factor problems. So starting with the top here, just jump right in. What's the dilution factor when you have 1 milliliter of your stock solution and 24 milliliters of water? Well, just like we were doing before, we added 1 milliliter to 24. So that's our total is going to be 25. So our dilution factor is 1 over 25, or 0.04. Here we do the same thing. We add 1 milliliter to 199 milliliters of water, so that's going to be 1 in our total here is 200. So that's going to come out to 0.02. And finally, we're adding, this one's a little bit different because it's not the 1 over x format, but it's just the same idea. So you're going to take 5 over your total. And then you can just reduce this to 1 over 100, which is 0.01. So those are your dilution factors there. Alright, let's try another kind of dilution factor problem. So this one, if we plug in the first part A here, we would the problem would read: a solution with a dilution factor of 1 over 200 can be made by adding 1 milliliter of stock to what amount of water? Well, luckily this is in the 1 over x format here, so we can see that there's 1 part in a 200 total. So that means that we added 1 milliliter of stock to how much water? A common mistake would be to say that we added it to 200 of water. But remember that this bottom number is your total. So we actually added it to 199 milliliters of water, because we can't forget about the 1 milliliter that we added. So your total is then 200. So the answer to this first one is 199. The second one here is going to be same idea. If we turn this into, try to turn this into the 1 over x form, we have 2 over 100, and then we can reduce it to 1 over 50 and treat it just like the above problem. So if we have 1 part in 50, and 50 total, we added 1 milliliter of stock to what amount of water? Just like the last one, it's going to be 49, because 49 plus the 1 that we added is going to equal 50. 49 plus 1 equals 50. Or rather, you should think, makes more sense to think about it as your total is 50, and you know that you're adding only 1 milliliter of stock, so you had to have added it to 49 milliliters. And then that's your answer here. Okay, and we treat this one just like the above. This is 5 in 1,000. And this can be reduced to 1 in 200. And then this is just the exact same as up here. So we think we have 200 total, and we added 1 milliliter. So one milliliter of that 200 milliliters is stopped. So we take that out to get what the water was, which is 199. Now let's take a look at this problem. We're steadily getting more and more difficult. So here, this is actually not too difficult. This is just like the first one that we worked with. Here it's asking what is the dilution from the original, which is, let me get my pen, which is here. We'll color code them. It's flask A. And that's just going to be what we added, which is 1 milliliter, over the total, which is 99 milliliters plus 1. So that's your first dilution factor between here. So now what's the dilution from flask A to flask B? Well, again, we took 1 milliliter into 99 milliliters, so it's 1 over the total is 100. Now don't get confused just because we've already done a dilution and try to change up the numbers and whatever. Your dilution factor, the dilution between two things, it doesn't matter what the original solution is. That only matters at the very end. So here, this third question here is when that's going to start to matter. So what is the dilution from the original to flask B? So now we know the dilution factor here, we know the dilution factor here, we multiply them across, and we get the total dilution. So it's going to be 1 over 100 times 1 over 100. Which is 1 in 10,000. Alright, so now let's talk about flask C. So B to C, yet again, is going to be, we put 1 milliliter into 99 milliliters. So again, it's just 1 over 100. Don't get confused and try to do anything fancy with this one, because obviously we already know that this is super diluted, but that doesn't matter. That doesn't matter unless you're doing a dilution from the original, like we did here. So this is just 1 over 100. Now this is another question that's talking about the original. This wants the total dilution. Like when we went through the steps, this wants the total ending dilution. So that means we got to add everything together. So it's going to be this one here, and this one here. One's being the dilution factors. So it's going to be 1 over 100 times 1 over 100 times 1 over 100, which is going to be 6 zeros. It's 1 part in 1 million. So you can see how this quickly went from a pure culture to 1 part in 1 million in just 3 dilutions. Here's another dilution question that's asking about the total dilution factor at the end of a serial dilution. So here we have some specimen, and it doesn't give us a starting concentration, which doesn't matter. It's just asking about the total dilution factor at the end. So just like the other ones, this is just the same that we've been doing. It's just the numbers are a little bit different. The numbers, don't let the numbers confuse you. So we're going to see what amount did we put into our test tube. What was our original specimen addition amount? And that was 0.5. We added 0.5. The part was 0.5. And the whole was, common mistake would be to say 4.5. The whole is actually 5. 4.5 plus the 0.5. So this is our first dilution factor here, which is just 1/2 over 5, or 1/10. So our first solution factor is 1 in 10. Now, we take this solution that we already made here, and we dilute it again in a series, and we take 1 milliliter and put it into 9 milliliters. So now we have our part is 1, and the whole is 9 plus 1, giving us 10. So that is the dilution factor here. That's the dilution factor here. So our total ending dilution factor is 1/10 times 1/10, which gives us 1/100. Alright, so let's look at an initial solution that contains 5 times 10 to the 8 cells per milliliter. So this one has a distinct starting concentration, and this is going to be important. As we said in our steps earlier, the first thing to do is identify your initial concentration. So there it is right there. Now we're just going to toy around with this and see how different dilutions change it up. There's no real question here, but bear with me. So first let's try to do a 100-fold dilution. So as we've been doing before, a 100-fold dilution can be done by taking one part, let's say 1 microliter of our solution, and adding it to 99 microliters of a buffer. And that will give us part over whole of 1/100, a dilution factor of 1/100, or a dilution of 100-fold. And then that would leave us with 5 times 10 to the 6th cells. Because, as we discussed before, you take your initial concentration times your dilution factor to get your ending concentration. Now, another way that you can do this, or a potential problem with this, is that 1 microliter is sometimes a little bit hard to work with because it's so small. So another way that you can do this is changing the volumes but keeping the ratio the same. So a lot of times it would make more sense maybe to take 10 microliters of our initial solution and 990 microliters of buffer, which is going to give us 10 in 1,000, or just 1 in 100 when reduced. As you can see, the ratio is exactly the same. Alright, so let's visualize this real quick. Here's our initial solution. We took 1 milliliter, added it to this test tube here, and we also added 99 microliters of water. And that ended up with a 5 times 10 to the 6th concentration. Okay, so let's take this a step further. Let's do an 1,000-fold dilution from this point. So we're going to take 1 milliliter of solution from this and add it to a new test tube with how much? 999 milliliters of buffer. I apologize for my rounded arrow here. So anyway, that's going to give us a dilution factor of 1 in 1,000. So now what's the dilution here? Well, we can either look at it as from the point of view of this second solution or from the original. The dilution factor between the second solution and the solution we're working with now is 1 in 1,000. If you go all the way back, it's going to be 1 in 100,000, because you would have to do 1 in 1,000 times 1 in 100. So let's just take it from here. 5 times 10 to the 6th times 1 over 1,000. It's going to leave you with 5 times 10 to the 3rd cells per milliliter. So hopefully this has given you a good base to start attacking more difficult problems. I focused here on some basics about dilution factors because that's the key to all of this. If you can identify your initial concentration and then multiply it by all of your dilution factors that you found and end up with an ending concentration, that's it. That's all you need to do. So if you can apply this to the most convoluted word problems and be fine. So if you have mastered what we've talked about in the last 20 minutes, you will be able to attack any difficulty problem and be successful.